Alright, welcome back. We're going to be working on a new way of solving quadratics today, and that's going to be using the process of completing the square. In order to help you out, I'm going to go through exploration number 1 with you, and I'll follow up by allowing you to go through exploration number 2 using what you've learned from this first one. I'm going to go ahead and use algebra tiles to demonstrate completing the square, and then we will move on to the algebraic work following that. So I'll be your partner today. We're going to use algebra tiles to complete the square for the expression x squared plus 6x. We're going to model that by using the square tiles for x squared and then your bar tiles as your x tiles. Now you can see here from the picture that we're already kind of moving ahead, but I'm going to go ahead and skip down to letter C and D here to kind of help us out. So the first thing I need to do is I need to get my picture, which is x squared plus 6x, to match up with the picture that is given. Now the term completing the square is from the actual process of creating a square out of these algebra tiles here. So what I'm going to do is I'm going to divide my number of sticks in half here. Now I'm going to move half of them here to this part of the expression, or this part of the algebra tile group. The next thing I'm going to do is I'm going to determine the total number of small ones pieces that I need to use in order to fill in the missing portion of the square. So I'll bring this one here, this one here, this one here, and you can start to get the idea of what the actual answer is going to be before I even finish filling it in. Alright, so what I'm doing here is I'm filling in the area of the missing piece, and the area is going to be this 3 by 3 square of unit blocks. So the answer to letter B is going to be 9. And then we're going to find the value of C so that the expression x squared plus 6x is what is known as a perfect square trinomial. Now the exploration here is to help you understand that the result of completing the square is what is known as a perfect square trinomial. Now from what we've learned already, a perfect square trinomial is a squared From what we've learned already, a perfect square trinomial is a plus or minus b quantity squared. And that always turns into a squared plus or minus 2ab plus b squared. The plus or minus will change only the second term there. So we need to figure out, by completing the square, what the perfect square trinomial is. And based on our exploration here, the value of C is the value of the number of these little unit blocks that are there. So the value of C is going to be 9. Writing the expression as a square of a binomial is very simple. We're going to do x squared plus 6x, substitute C for 9, or 9 for C, and then we can go ahead and rewrite that as a perfect square trinomial. If a squared is x squared, then a is the square root of x squared, which is x. If b squared is 9, then b is the square root of 9, which is 3. And the square of a binomial is x plus 3. So you're going to use that understanding to help you work through exploration number 2. I've gone ahead and given you some hints on your algebra tiles there that might be helpful for you when you're looking at this table to fill in. We're going to go ahead and discuss what happens here in the rest of the exploration at the beginning of class tomorrow. So please have your conclusions written down here so you can see clearly and discuss clearly what's going on. All right, let's take a look at some of our notes, sure that all written in place properly. All right, so completing the square is a process of adding b divided by 2 squared to both sides of a quadratic equation, thus forming a perfect square trinomial. Here's some steps that you're going to use to help you in completing the square. And I went ahead and filled out some additional notes that you're going to want to take in order to remember how to do this properly. So the first thing you want to do is you want to use standard form of quadratic equation. That's going to be ax squared plus bx plus c. But remember, there's a special rule that has to take place. The coefficient a has to be 1. If it's not, you have to factor it out. Then you're going to calculate b divided by 2 squared and add it to both sides of the equation. Now the reason you have to add it to both sides of the equation is because the equation must be balanced to get the correct answer. Equations are based on equality. Now this is an example of an unbalanced equation because I added the value of b divided by 2 squared to only one side of the equation. My equation is now out of balance. This is an example of a balanced equation because I added the value of b divided by 2 squared to both sides of the equation. An equation which is out of balance will always give you an incorrect answer. So please remember that when you're balancing an equation, you're adding whatever you added to the left side of the equation also to the right side of the equation as well. We'll have some examples that you can look through and start to understand how this is going to work moving forward from here. All right, so in exercises 1 through 3, you're going to recognize that you have perfect square trinomials and you're going to solve by using square roots. So I'm going to first recognize in question number 1 that that's a perfect square trinomial. I'm going to go ahead and write this up here. A plus or minus b quantity squared equals a squared plus or minus 2ab plus b squared. I'm going to use this as the basis of everything I do for the rest of the worksheet. So if this is a perfect square trinomial, then this is a squared. The square root of x squared is x. And if this is a perfect square trinomial, then this is b squared. The square root of 4 is 2. This symbol always matches that symbol, so that's how I know it's plus, and I write it as a binomial squared. Alright, the next thing I'm going to do is I'm going to square root both sides. When I square root both sides, I get two solutions. So I get x plus 2 equals plus or minus the square root of 2. And we're going to leave this in exact form, so we're not going to do anything with the square root of 2, we're just going to leave it put. Subtract 2 to both sides, and I get x equals negative 2 plus or minus the square root of 2. Because we're looking for exact answers here, that is an acceptable response. Alright, go ahead and do question number 2, and have question number 3 for tomorrow's practice. Alright, in this particular case, what we're looking for here is we're looking for the value of c that creates a perfect square trinomial. So what I'm going to do is I'm going to take a look at my examples and I'm going to decide how this is going to work. We'll look at question number 4 first. Alright, so I get y squared minus 14y plus c. I'm going to go ahead and move back up just a little bit so I can still see this. Alright, so what I got to focus on now is the value of b, the central term here. So that's going to be negative 14y equals 2 times a times b. Well, I know that a is the value of y because a squared is y squared. I don't quite know what c is yet, but I'm going to figure that out by using a little bit of logical reasoning. If 2 times b is 14, that means that 14 divided by 2 will give me b. So I'm going to go ahead and do that in my head, and I get y squared minus 14y plus 7 squared. Because remember, b squared is my last term. So rewriting this as a perfect square trinomial is going to be y plus 49. Now, because this is a minus sign, that means that the value of c is actually negative as well. So that's going to be c equals negative 7. Go ahead and try number 6 on your own and have question number 5 saved for tomorrow's practice. Alright, now we're going to get into the process of completing the square. I want to go ahead and look at question number 8 here to help us get started. Alright? So the first thing I want to do to make this easier for me is I want to isolate the part that I'm going to turn into a perfect square trinomial. And that's going to be the x squared and the x terms. That means I'm going to move the 28 to the other side of the equation so that I can focus specifically on the x squared and the x terms. So now I get x squared plus 10x equals negative 28. The next thing I'm going to do is I'm going to remember back to the exploration and the notes that what I'm going to do is I'm going to take the value of b and I'm going to divide it by 2. Now the reason I can skip step 1 is because I know that the coefficient of a is 1. So I'm going to go ahead and add that number, b divided by 2 squared, to both sides of the equation. So I get x squared plus 10x plus 10 divided by 2 squared equals negative 28 plus 10 divided by 2 squared. Now, when you get good at this, you don't have to rewrite this, but as far as I'm concerned, I'm going to continue to write this so that it's consistent, so you guys understand exactly where it's coming from and why I'm getting those numbers. Alright, so 10 divided by 2 is 5, 5 squared is 25. So this becomes x squared plus 10x plus 25 equals negative 28 plus 25. See the balance? I added 25 to both sides, so the equation is still equal. Now this is a perfect square trinomial, and if x squared is a squared, that means a is x. Now I ran out of space here, so I'm going to go ahead and I'll write it over here. So I get x plus, remember the symbols always have to match. If b squared is 25, that means that b is 5 squared equals negative 28 plus 25 is negative 3. Now it says to solve the equation by completing the square. Okay, well that's not too bad. I just completed the square, now I'm going to solve. So I'm going to square root both sides, alright? And I get x plus 5 equals plus or minus the square root of negative 3. And now I've run into a problem. The problem is that this is an undefined term, okay? But we haven't quite learned it yet. It's not undefined, it is what is known as imaginary. So I'm going to solve it, but I want you to understand that the answer to question number 8 is no real solutions. But to help us move forward from here, namely tomorrow, I'm going to go ahead and solve this as I will using complex numbers. So I'm going to replace the negative with the value called I. And now I get I times the square root of 3. I want to leave this exact, and I'm going to get negative 5 to both sides. And I get x equals negative 5 plus or minus I times the square root of 3. This is known as an imaginary solution. We're going to talk about this in tomorrow night's video, but I want you just to understand that the answer to this that's acceptable for right now is no real solutions, because you cannot have a negative number underneath a radical with an even numbered index. Okay? Alright, let's go back to question number 7. I'd like you to try that one right now by completing the square, and then save the rest for our exploration for tomorrow. Okay? Alright, I'm going to take a look at a couple more questions before we move on. The one that I want to look at specifically is this guy right here. The area of the triangle is 30. Find the value of x. Alright? So if the area of the triangle is 30, I'm going to go ahead and write 1/2 base times height equals 30. I'm going to fill in what I know, alright, the base being x plus 2, so it's going to be 1/2 times x plus 2 times 3x equals 30. I don't like fractions, so I'm going to go ahead and switch that to the other side by multiplying by the reciprocal, 2 over 1. And now I get hippity-hoppity distributive property, 3x squared plus 6x equals 60. Next thing I'm going to do is I'm going to go ahead and factor out the 3 so that the coefficient of my first term is 1. So if I divide out the 3 to everything, I get x squared plus 2x equals 20. Next thing I'm going to do is I'm going to complete the square, because that's what we're doing here. I just want to go ahead and keep practicing that. So my coefficient of a is 1, therefore I'm going to divide b by 2. So now I get x squared plus 2x plus 2 divided by 2 squared equals 20 plus 2 divided by 2 squared. Now I'm going to rewrite this as a perfect square trinomial. That's x plus 1 quantity squared equals, and that's 20 plus 1, 21. I'm going to square root both sides, and that's going to give me x plus 1 equals plus or minus the square root of 21. Subtract 1 to both sides, and the solution that I'm going to get is x equals negative 1 plus or minus the square root of 21. Now it's got to be only one of these, so we've got to figure out which one it's going to be, because I can't have a negative number over here as the value of x. So I'm going to go ahead and if I type these into my calculator, I can find my solution that way. But the most important part here is that you're actually looking for completing the square to find your solution. We're going to go through the rest of this during class tomorrow, so please be prepared to go over any questions that you still have concerning this particular method of solving quadratics, and be prepared to answer the rest of these questions tomorrow during class.